What's going on, guys? In this video we are going to see how to find mesh currents using mesh analysis method. In mesh analysis method, what we have to do is, the first step is we have to assign meshes for each loop. Here we have two loops, so we assign meshes for these two loops. These are going to be our meshes, right? So I1 is first one, and also I2 is going to be the second one, right? After that, what we have to do is we have to use Kirchhoff's voltage law, and in Kirchhoff's voltage law we know that addition of all the voltages should be equal to 0. So here let's start with the mesh one. So in mesh one we have this current going in this clockwise direction. So it's always better to keep this I1 and I2 in the same direction. In that way it will make things easier. If you assign clockwise, keep the other one clockwise. If you assign other one counterclockwise, keep this one also counterclockwise. It doesn't matter if you assign one of them clockwise and other one counterclockwise, but it's going to make everything harder. So this way it's easier. Now let's go ahead and do the Kirchhoff's voltage law for this first mesh. So first mesh, whenever we have this current going through negative to positive, we put a negative sign in front. So -4, and others are going to be through this resistor is going to be plus. And then here we know that V is equal to IR, right? So I1 is going through this 1 kilo ohm, so this is going to be 1 kilo ohm times I1. And through this one it's going to be a little bit different, because through this branch I1 is not only the current going through this, we have I2 also going through this one, right? So we have to put both of them. But to write the equation for this, what we do is we take this resistance first, 2 kilo ohm, and if you look at this one, we are looking at I1's direction. I1 is going to be positive and I2 is opposing that one, right? So it's in the opposite direction. So this is going to be minus I2. So this is going to be our voltage. We don't have anything else. So these are the voltage we have in the first mesh, and that's equal to 0. And this is our first equation. Let's simplify this one. This is going to be -4 plus this one 1 kilo ohm, and here we have 2 kilo ohm. So totally we have 3 kilo ohm I1, and we have 2 kilo ohm of I2. So this is going to be minus 2 kilo ohm I2 is equal to 0. Now let's go ahead and create another equation in mesh 2. Mesh 2, we have this current going through plus to minus. So when we have when the current goes through plus to minus, we put positive sign. So this is going to be positive 5, and after that this is going through this 2 kilo ohm again, and here it's going to be different than the previous one. Previously we look at, let's use a different colors right here. So previously we used I1's direction. Now we are looking at I2's direction. So we have to put positive for I2. So this is going to be 2 times I2, and this is going to be positive for I2, but I1 is opposing that one, so we are going to put negative I1, right? So because wherever you are looking at the mesh, so whatever the mesh you are having, that's going to be positive. So previously we had I1's, we are looking at I1's direction, and wherever the I1 going through the resistor is going to be positive. But whatever the other currents we have is going, if it's opposed, that's going to be negative. If it's along the path, that's going to be positive. So here we are looking at I2, and for I2, I1 is opposite. So that's going to be make this one negative. And through 3 kilo ohm, we have I2, so this is going to be 3 kilo ohm times I2. And these are the only voltages we have, and that's equal to 0. So this is equation 1, equation 2. Now we can go ahead and create our matrix, but before we create matrix, let's move these numbers to the other side. Also we can write this equation better way, like this is 2 kilo ohm actually, 2 kilo ohm. Let's simplify this one. This is going to be 5 plus, we have -2 kilo ohm I1 So this is a negative 2 kilo ohm I1, and we have 2 kilo ohm I2 plus 3 kilo ohm I2, that's going to be 5 kilo ohm I2, right? And that's equal to 0. This is our second equation. Now to arrange this one in matrix form, what we have to do is we have to move this numbers to the other side of equation, and also let's expand this one, like let's keep everything in terms of SI unit. So 1 kilo ohm mean it's basically 1000 ohm, right? So 1000, I'm taking the first equation. So let's write this one with a different color. Okay, first equation. Here we have 1 kilo ohm I1, that is 1000 ohm, right? 1000 ohm. And then we have, actually I have to look at the simplified equation. Simplified equation is right here. This is 3 kilo ohms of I1. So this is going to be 3000 ohm I1. So 3000 I1. And here we have minus 2 kilo ohm I2. So this is going to be minus 2000 I2. That is equal to plus 4. Because if I move this 4 to the other side, that's going to be plus 4. And this is our equation 1. Now let's look at the equation 2. Here we have negative 2 kilo ohm I1. So this is going to be negative 2000 I1. And we have 5 kilo ohm I2. So this is going to be 5000 I2. And in the other side, we are going to have negative 5. And this is going to be our second equation. Now we can go ahead and create our matrix form. Here we are going to have 3000 and then minus 2000 and minus 2000, 5000. And in the other side of the equation, we are going to have 4 minus 5. And actually this, we are going to use Cramer's rule, so we have to arrange this one like I1, I2, and then here we are going to have, this is 4 and this is negative 5. And Cramer's rules, what we do is we find the determinant of this one, and like for example, whatever the, if you want to find I1, you swap this one with the first column and then find the determinant. Let's say that is 1, and you also find the original determinant and divide by d, and that's going to give us the I1. So you can try it. Cramer's rule, that's going to give you I1 is equal to 1 over 1100 ampere, and I2 is going to be equal to negative 7 over 11,000. And if we simplify this one, that's going to give us 9.09 times 10 to the power of minus 4 ampere, and this is going to be negative 6.36 times 10 to the power of minus 4 ampere, and that's going to be our final answer. I hope you guys find this video helpful. See you next time.